Hello, everyone. Well, welcome to week number 2. You've made it to week number 2. Um, I'll tell you that we're going to be covering chapters 3 and 4. Now, chapter 3 gets pretty deep into scientific discussions and terms and theories, and some of the environmental theory folks probably will have a better grasp than maybe some of your others, but I don't want you to get too hung up on all of the scientific terms. But what I do want you to do is to have a basic understanding of why it's important to understand the purpose of this area of study within planning and how it relates to sustainability and resiliency. So with that, let's go ahead and dive into chapter 3. Okay. Chapter 3 goes into some explanation about living systems. Now, what you're going to notice throughout all of the chapters is a common theme of systems and connectivity. During this chapter, though, we'll briefly we're going to discuss energy and matter, the 4 spheres, ecosystems, which we kind of touched briefly on in chapter number 2, the resiliency of life, and the Gaia theory. So those are the things that you'll need to focus on in this chapter, so just keep that in mind. Now, anyone who studies science knows that the best way to study a theory or system is to create solutions and pattern their solutions after other processes that work. This is also the process of sustainability, and the one that sustainability practitioners, they try to pattern their solutions on sustainable living systems that operate and endure over long periods of time. So we do this primarily because nothing about the physical world is ever static. It's constantly changing to meet the environment. There's always a transfer of energy and movement of matter in the physical world, and that's often hard to see. Cycles generally happen on a scale that may be microscopic or very vast. So, as I mentioned in module number 1, a system is a whole which is made up of many parts and is constantly changing, as we've said. Now, the technical definition of energy is the ability to do work. Now, matter is the name given to all physical substances. It can be stored, it can be transferred, it can move around from one system to another. The diagram that you see on the screen is it kind of shows the cycle of systems and the transfer of energy. Energy only flows in one direction. That is because it is produced by a reaction within a system, it's used up within its processes, and then it ultimately goes away. Now, matter, on the other hand, does not go away. It can't be created, it can't be destroyed, and it consists of elements which are made up of atoms, which cannot be broken down any further by ordinary means. Now, thermodynamics is the study of the transformation of energy. In any system, though, energy comes in, that energy that comes in actually must equal the energy that goes out. So the Earth is divided into 4 interconnected geospheres. Now, these are all, all of these spheres play a major role in the overall system and the Earth. These are the lithosphere, the atmosphere, which includes the troposphere and the stratosphere, and then the hydrosphere and the biosphere. Now, these areas are very easy to distinguish just by their name. Now, the lithosphere, meaning litho meaning stone, is the area, of course, of the Earth, which is the rocky crust that covers the planet. Now, the atmosphere, meaning air, is the body of air that surrounds our planet. I mean, a lot of you probably remember this from, perhaps geology, or if you've taken any type of geomorphology or something like that, you probably have talked about these. Now, the atmosphere is broken down into 4 different layers called the troposphere, which is the lower layer. It's the lowest layer. And it continues upwards with the stratosphere, the mesosphere, the thermosphere, and finally the ionosphere. Now, the hydrosphere, hydro meaning, of course, water, is composed of all of the water that is on and near the Earth. This includes the moisture in the air, the lakes, rivers, oceans, groundwater, etc. Finally, the biosphere, bio meaning life, is composed of all living organisms, no matter how large or how small. Now, ecologists study ecosystems at many different scales, from the micro level, or the individual, to the macro level, or the biosphere. Now, a population is a group of individuals of the same species. A community is all of the populations that live in the area. An ecosystem is the community plus everything else, the rock, the soil, the water, the air. And it is a combination of living and non-living parts, with each part playing an important role. Now, the biome, in simple terms, is just a set of ecosystems that share similar characteristics with their abiotic factors, which is the non-living forces that cause adaptation. Now, the biosphere, all of those are the different biomes, each blending into each other. This is a huge community of plants, animals, and humans in their defined habitat. Now, it's the sum of all of the ecosystems on Earth. And the chart on there kind of gives you an understanding of each breakdown of all the ecosystems. Now, this overall discussion could be deep on so many different levels. Now, we're going to make it a little more simple than what it really is. The constant flow of energy and matter within the rather complex network structures of life means that new forms and structures can emerge spontaneously. Now, this is a feature of life called emergence. Now, systems will quite often need to accommodate disturbance and while retaining basic functions and structure. Now, this ability is called resilience, which is the ability to react and recover from disturbances. Now, this is very important. This is one of the areas that Margaret Robertson actually added to her book, a little bit more on resiliency. And when we talk about this, and we're going to be speaking more on resiliency and systems being resilient. And as planners, what we need to do is focus on making sure that these systems, whether it's a community or whether it's a process within a community, say a county government, those departments of a county government, the businesses in the area, that they all can, they have the ability to react to any type of disturbance, weather or man-made type of disturbance that may affect them, and rebound from that. So essentially, that's really what we're talking about when we talk about resilience. Okay, chapter 4 is focused on the human element of sustainability. Now, it's the multidisciplinary issues of poverty, health, overpopulation, resource depletion, which we constantly have to face, food and water scarcity, political instability, and the destruction of the biosphere, which, again, are all connected. Now, the problem only increases when the population increases, and of course our population continues to grow and grow and grow. Now, listed are some of the key highlights of Chapter 4. What you'll quickly realize is that this chapter is about population growth, and that population growth creates a very large challenge when it comes to being sustainable. Now, prior to the existence of man and woman, the world had achieved a state of equilibrium. I mean, the processes, the system of the earth continued to work the way it needs to work, and so it was in a state of equilibrium, minus some things coming from the outside, such as meteors and that type of thing, which could cause disturbance and some, of course, causing some major problems. But as you'll learn, I mean, these again are going to quickly change as population increases. Now, there are three pillars of sustainability: environment, economics, and equity, which we talked about in previous chapters. They're all greatly impacted by one factor. That's humans. Now, the equilibrium of Earth systems continues to be unbalanced by the increase in human population. Now, the human impact on the planet is calculated based on the carrying capacity. Now, that's the number of individuals that an environment can support without degrading the population's ecosystem. Now, our planetary system is far from being sustainable, as it currently operates at 140% of its capacity. Now, if all humans on the planet lived the same standard of living as the U.S. and Canada, we would need 4.5 more planet Earths, even if the population didn't continue to grow. Now, as you've been able to probably deduce, the human population is really the spark that started the fire towards an unsustainable planet. Now, the human population continues to go through stages. Starting out, humans were, of course, hunter-gatherers with very low life expectancy due to the small amount of food available, and even some diseases that were around that were uncurable or what have you. Following the Ice Age, though, conditions warmed, rain increased, soil became filled with nutrients, and then that's when we entered the agrarian period, where people were starting to farm. Nomads finally began to settle down in one spot, would farm the land, and would raise families. This led to people having more food, of course, used to barter for supplies and services, and which started to invent new technologies and tools and that type of thing. So humans began creating complex societies, and the Earth's population steadily increased. The agrarian time period soon followed by the Industrial Revolution, after increased technology caused a boost in agricultural production. The increase in the use of fossil fuels such as coal and increased petroleum, which caused power farm equipment and increased productivity or production of crops as well, also required less people. So by 1804, the Earth's population reached approximately 1 billion people. Another key component to the population growth was the improvement of sanitation, vaccines, and antibiotics due to the advancement from Louis Pasteur and many others. Now, in 1930, the population of the planet went from 1 billion to 2 billion. So you can see in a very short time period that number rose, and it only continues to rise. So population growth, it continues to grow exponentially, but it has not remained constant. There's a rule of 70, which was designed to estimate compounding periods in all areas of study. It's a kind of a quick but rough way to calculate how many years it'll take for the human population to double. Now, the book gives this example. If the quantity such as population is growing at 2%, it will double in 70 over 2 or 35 years. Now, this definitely isn't a perfect method, of course, because things kind of ebb and flow. And the population, of course, changes based on disasters and famines, wars, that type of thing. But the study of growth, of growth and the decline and the change of population is called population ecology. Now, once we apply statistical principles to human population, the science is called demography. So there are a few areas that must be considered for population growth. Okay, so those are the birth rate, or the total number of people born in a given year, immigration rate, or the number of people moving to an area due to migration, and of course the death rate. Now, if the birth rate and the immigration rate is greater than the death rate, then it will grow. If not, then it will decline. Other factors to be considered when calculation population projections are the total fertility rate, which is the number of children born per woman during her lifetime, and the replacement fertility rate, which is the number of births per woman that will keep the population size constant at zero population growth. And there are a lot of folks, a lot of planners actually just focus on population overall. And so, I've never been great at population projection, but certainly there are some folks who are really good at population projection based on these formulas that we kind of just barely touched on. Now, demographers, they expect 4 trends in the world's human population over the next 50 years. The population will grow older than it was in the previous century and bigger than it is now. It will continue to grow, but at a slower rate. Migrations will continue, and or populations will be increasingly urban. Now, there have been many efforts to help stabilize population growth around the globe, whether by forceful means. An example is China's one-child policy, which they have since changed, or national tax policies, which put strict restrictions on maternity or government housing benefits, such as Singapore. Whatever the case, 3 dimensions of social progress are essential to stabilizing the population overall. That is education, employment, and reproductive health. The empowerment of women and their ability to work instead of having children had a really large impact on communities and the number of children that were born, and overall the community's poverty level. Therefore, it reduced the population growth rate. Now, fortunately, the efforts have been working by whatever means to reduce the rate of increase, even though population numbers continue to grow. Now, the charts you'll see on the screen, they kind of show that trend. To future slow down that trend, the UN adopted a set of 8 goals aimed at having extreme poverties in all form, since poverty spawns population growth. To eradicate extreme poverty and hunger, to achieve universal primary education, to promote gender equality and empower women, reduce child mortality, improve maternal health, which is expanding universal access to reproductive health care, combat HIV/AIDS, malaria, and other diseases, ensure environmental sustainability, and develop a global partnership for development. So in the last 50 years, the population has doubled, global water consumption has tripled, and the use of fossil fuels has quadrupled. So obviously not a really great situation, not a great equation here. Analyzing all of those areas is going to lead you to one conclusion, though, and that is the driver of all change are economic. The myth is that the economic growth model is sustainable as is. That is a very false myth. Economic growth is not sustainable. Why? Well, because it takes non-renewable resources to create product efficiency, or rather efficiently, to make money. Additionally, the current economic system releases waste into the environment faster than the natural system can process it. So we consume renewable resources faster than they can be replenished. It's trees and water, etc. And non-renewable resources, oil is a good example, is being used up at a rapid pace and cannot be replenished. Now, of course, there are many scholars that are, who were a part of explaining economic growth and the challenges, some of them including Adam Smith, who wrote An Inquiry into the Nature and Causes of the Wealth of Nations, now just called the Wealth of Nations, Karl Marx, and Thomas Malthus. Make sure you're familiar with that. The book kind of goes into those folks, and so make sure you're familiar with what they do and what they did. So globalization, which is also known as economic openness, is a controversial driver of economic growth. It does have a positive effect on the well-being and economic health overall. However, beyond certain thresholds, globalization can contribute to social inequity and environmental damage. Now, economics is the study of how to allocate limited resources among alternative or competing interests. Modern economists, they fall in three categories. First, the neoclassical economics category, the environmental economics, and the ecological economics category. Each one of these has a specific area of study. The majority of economists fall under the neoclassical, in which supply and demand is the model. Now, it's the idea that the market will decide the optimum alternative. Now, microeconomics, or the viewing things at a very small scale, and macroeconomics, the big picture, falls under this type of study. Environmental economics considers economic values. They assign values to ecosystem services. Remember, this is the biological functions that support life, in order to incorporate them into markets. Now, finally, ecological economics, they see things at a holistically at the micro, or the macro level. It recognizes that since the planet is filled with billions of people, economics and ecosystems are interconnected in important ways. Now, as you'll read the book, as you read this chapter, understand some of the basic concepts of economics, such as sustainable development, or the increased quality of with a quantitative growth in consumption or production. Also understand the flaws of the growth market and how to reconfigure a growth market to be more sustainable. Okay, that's it for Chapter 3. Hopefully that will give you a good overview of this chapter, Chapter 3 and Chapter 4. Remember, just understand the reasoning. Don't get too in depth for Chapter 3 on some of the science, the science of it all. Just understand why it's important. And so, if you have any questions, feel free to send me an email, and I will respond to you right away and help you out. Until the next module, again, we will hopefully help you through that one as well. So